Right, students. Now we are going to discuss application of Laplace transform. That is solve differential equation using Laplace transform. So let's say if our equation is uh, let's start with an example just to be so dy by dt minus y equals 1 and y of 0 equals 0. We have solved these equations, this type of equations before. Let's just solve it without Laplace transform, just to recall what are we looking for. Clearly, we can send y on the other side, and now it's a separable equation, and we can write dy over 1 plus y equals dt, and that means log of 1 plus y equals t plus a constant. If we put y of, uh, or we can take e power if we want to. So we take e power on both sides, e power log of 1 plus y equals e power t plus c. So that means 1 plus y, because e and log will cancel each other here. And 1 plus y equals e power t plus c. Which of course if we put C1 here and we can rename the constant. If you remember, we have done this step in temperature and those problems, so we can rename the constant as C e power t, and this implies shouldn't this be implies, yeah, this should be implies, right. So this implies y of t equals C e power t minus 1. If we put the initial condition y of 0 equals 0, this implies 0 equals c minus 1, or in other words, c equals 1. So our answer is y of t equals e power t minus 1. So that is our answer. But we did not use Laplace transform to solve the equation. We have just solved the equation the way we used to solve the equation. So in other words, from this equation, what do we find? We find y of t. Okay, so that's what we are looking for. We are looking for a function of t, y as a function of t, as an answer. When we take Laplace transform of the same equation, what happens? So let's say we take Laplace transform of the equation dy over dt minus y. Of course, you cannot take Laplace transform only on one side. We have to take Laplace transform on both the sides. So we take Laplace transform on both the sides. Now what is going to happen? Laplace transform of derivative. First of all, what is Laplace transform of the derivative? And what is Laplace transform of y? We don't know what y is because we have to find y. Okay. Now we are solve differential equation using, let's move it a little bit down. Using Laplace transform. So we take Laplace transform on both sides because we know Laplace transform can split over minus. So we make two separate transforms here on the left hand side. Now Laplace transform of the derivative y prime of t, or dy by dt, same thing. S capital Y, well, this S doesn't need to be that big. S capital Y S minus small y0. That's the formula. That's the formula for Laplace of y prime of t, where Laplace of y of t, okay, y or y of t, same thing, is y of s. Okay. So when we take Laplace transform of anything, it becomes function of s, We know that already from our formula sheet. When we take Laplace transform of a function of t, it becomes function of s. K is constant here. So we take Laplace transform of function of t, it becomes function of s. What if we don't know what the function is? For example, if we take Laplace transform of y of t, we don't know what y of t is. So we say it is some function of s. Okay? We could have used any variable here like capital Y or capital W or capital Z, but because this is small y, so we use capital Y just to keep the relation. So here we don't know what y is. We have to find because we have to solve the equation using Laplace transform now. So we don't if we don't know what y of t is, then what is the Laplace of y of t? It is y of s. And what is the Laplace of y prime of t? It is s multiply y of s, capital Y of s, which is here, minus y of 0. This is known. This thing is known. How this thing is known? It is given in the question. Y of 0 is given in the question here. Y of 0 is given in the question, small y of 0. So we do not need to worry about this part. Capital Y of s, we don't know what this is. We have no idea what capital Y of s is, but we will see. So now equation after taking Laplace transform, it becomes s y of s minus y of 0, that is for this one, okay, formula which is given over here, okay, minus Laplace of y, which is again capital Y of s, equals 1 over s. What do we know from this equation? We know this thing. We know this thing. That is given in the question, y of 0. Y of 0 equals 0. That is given in the question. We know this thing. So let us put that and get rid of it. S y of s minus 0 minus y of s equals 1 over s. Right. So y of s is a function which we want to, which we don't know but we want to find out. Okay, y of s. Here is y of s and there is y of s here. We can take it common. Okay, y of s take common and we get s minus 1. It's a standard common. So just like we do, well, let's say x f minus 3f. So you can write x minus 3f, just like that. So it's a very standard common. Right. Now we have we can find y of s from here. Just send this thing down here. Okay, 1 over s minus 1. Okay, just like if we have 4 here, then this x minus 3 will go down. Okay, so f will be written as 4 over x minus 3. Okay, so s minus 1 goes s minus 1 goes down. Okay, so it multiplies over here with this s which is already down here. So let's go back. So we start with this differential equation. We take Laplace on both sides. Laplace, then we split. We know a formula, this formula here, that tells us that the derivative, Laplace of the derivative is sys, capital Ys, minus small y0. And Laplace of y is simply capital Ys. Okay, again, just take it as a formula. Laplace of 1 we know from the formula table that Laplace of 1 is 1 over s. Laplace of 1 is 1 over s. Right, here. Right. So y of 0 is given in the question. It is 0, so we put 0, and then we take y of s common, and then s minus 1 goes down. Now we have y of s. But that was not the objective. Our objective was to find small y of t, not capital Y of s. How do we get from here? How do we find small y of t? Okay. We know what is y of s? Y of s is Laplace of y of t. How do we get y of t from here? We take inverse on both sides, inverse on both sides, inverse on this side, and inverse on this side. This will become y of t. That is how we find y of t. So from here, now we take inverse on both sides. We take inverse on this side. We take inverse on this side. And this side becomes y of t because inverse of y of s is small y of t. And that's what we want. But now we have another problem. How do we calculate inverse of this thing? As you remember, I hope that we can use partial fractions because these are two linear terms multiplied. So we write 1 over s, s minus 1, a over s, b over s minus 1. This will implies 1 equals a times s minus 1, b times s, multiply this thing on both sides. Okay, and then we put s equals 0, the first one, s equals 0. That gives 1 a times minus 1 plus 0, or in other words, a equals minus 1. Then we put s minus 1 equals 0, the second one, come on, and that implies s equals 1, and this implies 1 equals a times 0 plus b times 1, or that would be b equals 1. So we have b here, we have a here. So our question, y of t equals Laplace inverse of a over s plus b over s minus 1. We can split Laplace inverse minus 1 over s plus Laplace inverse 1 over s minus 1. What is Laplace inverse of 1 over s? No, minus can go outside. Minus is not a problem. 1 over s. Laplace inverse of 1 over s is 1. Okay, so this is minus 1 plus 1 over s minus 1 here, 1 over s minus 1 here. Okay, and that is e power t. Okay, so plus e power t, and that is our y of t. Let's see if we get the same y of t as we did without Laplace. E power t minus 1, exactly the same as we got e power t minus 1. So how do we solve a differential equation using Laplace transform? First, we take Laplace on both sides. Do not forget the right hand side. That's a very common mistake students do, that they forget the right hand side. So take Laplace on both sides. On this side, split the Laplace on 2 terms, 3 terms, as many terms you have. Use the formula for y prime. For y, it is simply capital Y of s. And then if well, not only if, we always know what is y of 0, just put the value here, then collect the terms on y of s, send the multiple to down there, take inverse. Why take inverse? Because we want to find y of t, and take inverse. This will become small y of t, and this side will give L inverse of s minus 1. Right. And then this case we had to use partial fractions, but I think most of the cases we have to use partial fractions. In some cases it might be without partial fractions, might be direct, but whichever the case it is, just find the inverse and you will get the answer. Right. Let's try one more. Let's see which one shall we try next. It's question number 34 in the book, I think, but I'm going to modify it somehow. Our book likes the number 5, uh, using number 5 in the questions, so they have given cos 5t, but I have a problem with 5 because 5 and s when we write 5 over s square plus 25. So it's very difficult to understand which one is s and which one is 5. That's why I usually change 5 with some other number, 3 maybe. Okay? That's easier to understand. Okay. All right. So we have, and of course, always we are given the condition y of 0 equals 0. Well, it can be non-zero. Luckily, in these two examples, it is 0, but it can be non-zero. We will do example later in which it will be non-zero. Okay. So, okay. So we have to solve the differential equation using Laplace transform. Standard procedure. We start with taking Laplace on both sides. So y prime minus y equals Laplace of 2 cos 3t, right? Let's look at 2t, just that will give smaller numbers, easier to handle. Yeah. All right. So on this side, Laplace of y prime minus Laplace of y equals 2 times Laplace of this 2 is constant. This 2 can go outside, but this 2 cannot go outside. This is our k. Okay, sorry. Laplace of y prime is s capital Y of s minus small y of 0. Remember, capital Y of s means already Laplace is taken, and this one is the given condition in the question. Minus capital Y of s. What is cos 2t? Laplace of cos 2t, s over s square plus 4. So this becomes 2s over s square plus 4. This 2 is up here. Okay, this 2 is only 2 square, that's down here. Okay, so once again we put s y of s minus 0, that's given in the question, y of 0 here. Okay, this one, y of 0 is 0, and that goes 0. Minus y of s equals 2s over s square plus 4. Now we take common. Kind of standard steps, as you notice in the previous question and in this question, more or less very standard steps. Okay, we are doing almost exactly the same steps. Now we write y of s, which is equal to 2s over s minus 1 and s square plus 4, right? And now we need to find y of t. Okay, for y of t, we take inverse of y of s. Do I need to take inverse on the second side as well, or is it okay? That will give me y of t. What do you think? So Laplace inverse of y of s, Laplace inverse of y of s is small y of t. Okay, and this side I can write small y of t. What do we do on the right hand side? Do I need to take inverse on this side as well? If I do, how do I solve it? Pause the video and think about it, please. What do I do on the right hand side? Okay, so because we have taken inverse on the left hand side, we must take inverse on the right hand side as well. We do not have a choice. Okay, so our y of t is Laplace inverse of 2s over s minus 1 s square plus 4. Okay, now again we can see linear and quadratic, it's a partial fraction. So we start with our partial fraction, s minus 1 s square plus 4, and that is a over s minus 1 bs. And then we multiply this thing across. Here it cancels. Here s minus 1 cancels and s square plus 4 is left. Here s plus 4 is cancelled and s minus 1 is left. because we have one linear term. So we put s minus 1 equals 0, and that gives s equals 1. And this implies 2. When we put s equals 1 here, s equals 1 here, this gives 2. A, s equals 1 here, that gives 5. There is 5 again, you see. The more I don't want it, and there it is back again because I put 2. Okay. So 1, s equals 1, 1 plus 4, 5, plus bs plus c, and 1 minus 1, 0. So this goes away, and our a equals 2 over 5. Yeah, you see, I don't like 5 in these questions, and we have 5 in this question. Yeah. Right. Please do not put s square plus 4 equals 0. No, don't put. This will not work. This. Do not use the quadratic term equal to 0. Okay. Only the linear term we can use as 0. Okay. If it was s square minus 4, if it was s square minus 4, then we could have factorized it, s minus 2 and s plus 2, okay, here in the top. If it was s square minus 4, but it is not s square minus 4, it is s square plus 4, so we cannot factorize, okay. So we cannot put equal to 0. Okay. To find the other two constants, we will do comparing coefficients. So 2s equals as square plus 4a plus bs square minus bs plus cs minus c. So we compare s square, no s square on this side, so 0 equals a plus b. Compare s, yeah, there is one s here, so 2 is the coefficient, only the coefficient. Here no s, no s, this one is s, so minus b, and this one is s plus c. Compare constants. No constant here, so 0. No constant. 4a is a constant. How do we know that 4a is a constant? How do we know that? That 4a is a constant? Because no s with it. S here is a variable. S is a variable. 4a, no s with it, so that's why it is 4a is a constant. And minus c is a constant. Do not forget minus. Minus comes with it. Now we already know a, so that will help us. This gives b equals minus a. That means b equals minus 2 by 5. Okay. And from here we can write c equals 4a, and that means c equals 8 by 5. Multiply that. Lots of 5, you see. The more I don't like it, and more I got it by the wrong choice of 2 in cos. Okay. It's okay. Right. So now we have y of t equals Laplace inverse of a over 2 root 5 over s minus 1 plus bs. So minus 2 over 5 s. Yeah, you see, that's the problem. I'll start using 5 with different color for now, so that you are not confused. So 5, 5, and 5. So this is 5 and that is s. Okay. Over yeah, bs plus c plus 8 over 5 over s square plus 4. Okay. Yeah. All right. So now we have to split. Laplace inverse of 2 by 5 can go outside. So I'll write this 5 as well with that. Okay. So 2 by 5. 2 by 5 can go out. Yeah, that would be a problem, won't be? S, and here we write again minus 2 over s plus 8 over s squared plus 4. This is 5 and this is 5. This one is almost done. So 2 by 5 e power t. Okay. This one we split again into two. This one separate, and this one separate. We have done this in our last slide, last video. So I'll go simply straightforward. Minus 2 by 5 and Laplace inverse of s over s square plus 4 plus 8 by 5 Laplace inverse of 1 over s square plus 4. This is 5 here, this is 5, and this is equal to 2 by 5 e raised power t. S over s square plus 4. S over s square plus 4 is cos, 1 over s square plus 4 is sine, but sine also as 1 over k. Okay, so we must remember. This one is cos, so this one is 2 over cos 2t plus, it will give 1 by 2 outside, so 8 by 5 into 1 by 2 sine 2t. And there is a 5 here, and a 5 here, and a 5 here. And if we would like to write it again, e raised power t minus 2 by cos 2t plus this 2 and 8 will cancel and make 4, and sine 2t. This one is 2t. Just let us write it a little bit more clearly. And as you know, this one is 5. Okay, I've written 5 with red color so that it does not confuse you in the question that which one is s and which one is 5. All right, so we have our answer, and this is our y of t. If you can, I hope you can actually solve the same equation without Laplace. Go ahead, do it, and compare if you get the same answer. I hope you will. All right, now you will get a small quiz at the end, and do the quiz and come back.